Hey guys, it's Jenna from the Belleville Learning Academy. In this lesson, I'll be showing you how to balance a chemical equation. The reason why we balance a chemical equation is due to the law of conservation of mass. What that means is that the mass of the reactants must equal the mass of the products, because mass is neither created nor destroyed, but rather it is conserved. So the number of atoms on the left side must equal the number of atoms on the right side. That's why you add coefficients to balance. The simplest way to do this is to write all the elements out. So starting with hydrogen, you have 2 hydrogen atoms on the left side because of the subscript 2. And on the right side, you have 3 because of the subscript 3 and NH3. So the common thing between 2 and 3 is 6. So we multiply the H2 by 3 and the NH3 by the coefficient 2, yielding in 6. Now for nitrogen. The subscript 2 in N2 means that you have 2 nitrogen atoms on the left side. And on the right side, the coefficient 2 means that you also have 2. So the equation is now balanced. But if you look on the left side, the N2 has no number in front of it. It's called lazy ones, which is absolutely optional to write. And if nothing was written there, it's understood to be 1 because it needs no coefficient to be balanced. Also, another tip, if you look on the right, the NH3, that is one molecule. So if you put a coefficient in front of it, the coefficient applies to all the elements in that molecule. So 2 gets distributed to the nitrogen, meaning 2 nitrogen atoms, and then the 2 times 3 hydrogen, yielding in 6. Now let's solve a slightly harder example using parentheses. So again, we are going to lay all the elements starting from aluminum. On the left side, there is 1 aluminum, and on the right, there is 2, because of the subscript 2. Now, 1 and 2 is obviously not balanced, so we need to add coefficients. The lines I drew are to place the coefficients. So to make the 1 into 2, you multiply by 2 using a coefficient. So now they're both balanced. Now Br, bromine. On the left side, if you see the subscript 3, that means that 3 times 2, you have 6 bromine. Don't think that there's 3, you have to multiply the coefficient by the subscript. So that gives you 6, because the coefficient applies to aluminum and the bromine. Now on the right side, you have no coefficient, so it's 1. 6 to 1 is obviously not balanced, so if you do 6 divided by 1, that equals 6, so then you could multiply by 6. You multiply the KBr by 6, so now it's 6 to 6, they're balanced. Now for the next element, potassium K. On the left side, you have 2 because of the subscript 2. On the right side, you have 6 times K equals 6. 2 to 6 is not balanced, so 2 times 3 would give you 6. So we added a 3 in front of the K2SO4. So now 6 to 6, they are both balanced. Now on to the next one, SO4. If you look on the left side, you see SO4. But do not forget the 3 as a coefficient. You multiply the 3, meaning there are 3 atoms, or molecules, I should say, of SO4. And on the right side, you have the little subscript 3, so now our equation is balanced. A little tip is when you have a coefficient in front of a parentheses, make sure you distribute that coefficient to every single element in the parentheses, because it applies to both. Also note that the little numbers at the bottom in small handwriting, you cannot change those because those are subscripts, so you can only change the coefficients. This was Jenna from the Belleville Learning Academy. Thank you so much for watching, and subscribe down below for more videos.